Yo, 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 should I play music? Probably not. I think we did. We're gonna do. I think we did this one. Submitted that one. Guess higher or lower. We are given a guess game. The game is as follows. I pick a number one to n. You're given a you have to guess which number I picked. Every time you guess wrong, I will tell whether I guess wrong. Picked higher or lower. Okay. You can call a predefined API int guess int num, which returns three possible results. Your guess is equal to the number that I picked. Okay. Is either bigger or smaller. Okay. Pick. There's no pick. What?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem guess number higher or lower. We're playing a guessing game basically. We're given a range between 1 and n, where n is going to be the parameter that we're given in our function. Somebody has picked a number between 1 and n, and our goal is to guess which number that they pick. Now, if we get the right guess, if we guess the correct number, well, basically, first of all, how we can actually guess is by calling some API function that we're also given. We don't have to implement this. We just assume that it exists. So we guess a number, and if we guess the correct number, this function is going to return 0. If we guess a number that's too small, the number that we guess is smaller than the correct number, then this function is going to return 1. If we guess a number that's greater than the actual number, then this function is going to return -1. Using this information, we're supposed to efficiently implement a solution that can get the correct number. So if we were given n equals 10, that means we're given a range 1 through 10, and the correct value that we're trying to guess is 6. So how can we efficiently do that? Now, of course, the guess could have been something else. It could have been 7, it could have been 1, it could have been 10. We need to create a general algorithm that will be relatively efficient. Now, the worst case would be pretty obvious. So we're given 1 through 10. Now, the worst solution we could do is guess, let's say the smallest number. We guess 1. They tell us that the actual guess is greater than 1 based on the API function. So then we know, okay, 1 is not the solution. And now we're searching this entire range. Another bad thing we could do is guess the largest number, 10. Okay, 10 is not the correct solution. The real solution is smaller than that. So now we're still searching these. But of course, if we pick the middle number, that will eliminate the most possibilities, because either we guess the correct value, but if we don't guess the correct value, in this case, 5 is actually smaller than the real value. So not only did we eliminate 5, but we actually eliminated every value smaller than 5 as well, because they told us that the real number is greater, so we eliminated basically half the array. So now we're going to be searching this. And this is kind of a game. If you ever played it as a kid, you probably already knew this strategy, and it turns out that this strategy is actually a algorithm in computer science called binary search. And the good thing about it is, in the worst case, if we keep doing this, so now let's say this is the array that we're looking at, and we're not going to guess 6 immediately, because even though it turns out that that is the correct answer in this case, in the general case, that would not be very efficient. So we're going to again guess the middle value, 8. We're told that the real solution is smaller than 8, so now we've eliminated 8, but we also eliminated every value greater than 8. So now among these, we guess the middle value. I think it's going to end up being 6, because we're going to guess the middle value by taking 6 plus 7, dividing it by 2, and we're going to round down, so I think it's going to be 6. So this time we guess 6, and it turns out that's the correct value, so that's what we can return. Now with the naive algorithm, where we guess 1 by 1, that would obviously run in big O of n time, but if we always guess the middle value, every time we're going to be basically taking half the values of this array and eliminating them if we don't get the correct one. How many times can we eliminate half of the values of an array before we're left with a single value? Well, that's by definition the log base 2 algorithm, where n is going to be the input parameter n, which is also the size of the amount of numbers that we have. So the algorithm is log n, and there's no extra memory, so the memory complexity is big O of 1. With that said, let's now jump into the code. So with binary search, what you want to do is keep track of what your boundaries are. We don't have to have an actual array. In this case, we can just keep track of what the leftmost and rightmost values are, because those are like our minimum and our maximums. So the left, we know that this is a range between 1 through n, so our left is 1, our right is n, and we're guaranteed that there is a solution. So what I'm actually going to do is just set a while loop, and we can set it to while true, or you could set it to while left is less than r. I'm just going to set it to true, because we know within this loop we're going to end up returning once we find the solution, and we're guaranteed to find the solution. So now we want to calculate the midway point. We can do that pretty easily just by taking left plus right, dividing it by 2. With Python, you need 2 slashes to actually do integer division, which is how you can actually round down. Okay, so now we're going to guess. We can call the guess function. The middle value is going to be our guess, and then the result from that, we're going to need that result in a couple comparisons, because we want to know if it's greater than 0, is it less than 0, or is it exactly 0, which is going to be the else case. If it's exactly 0, that means we found found the correct solution. The correct solution is m, the midway point that we calculated, so that's what we can return. Now, if it's greater than 0, based on the description, that means that the real number is actually greater than our guess. So now we want to shift the range. We want to guess all numbers greater than m. We can do that by taking our left boundary, setting it to be equal to m plus 1. Now, in the opposite case, that would mean that we're trying to find the guessed number, which is actually smaller than what we guessed. That means the
Okay, a normal binary search. I'm not looking at it. I'm just gonna freestyle that shit. So wait. So guess int number is a thing. Okay. I need to guess whether it's smaller or bigger. Cool. While fuck you, nigga. While true, what that mean, nigga? Apparently this works. I don't know. I don't know why it works. Well, okay. I don't get it. It'll guess number. Some of these gets used down the line too. So yeah, the bitmap tree, like you know what I mean. I don't think I need this. So let's look into this and more tree questions, which is fun.
It's me, Abdullah. Well,
Why does he talk like that?
hey everyone, it's me, Abdullah. Welcome back. I do lead code and stuff. You can check out my lead code problems and videos. And if you have any kind of questions, you can ask them in the comments or just on my Instagram, Abdullah956. So, anyways, we'll be doing another lead code today 374, guess number higher or lower. This is an easy one playing a guess game. There is a game as follows. If I pick a number from from 1 to n, you have to guess which number I pick. Okay, every number you guess wrong, I will tell you whether the number I pick was higher or lower. Then your guess again. You can call a pre
If it's bigger, if your guess is bigger, I don't know why I'm calling res. It's called a. If your guess is bigger than zero, bigger than zero, what? Why is it bigger than zero? Why does this work?
predefined API and guess, and will be passing it number which return three possible results. Your guess result is higher than the number, it will return minus, and if it is lower, it will return 1, and if it is equal, it will return 0. So that's it. We were doing it by binary search and just cutting out in half until we reach our guess result. So we'll be starting from 1 because they will be starting from 1. So R will be equal to n while left is less than equal to r. We'll be computing our mate, and l plus r down dividing it by 2. So if this res is less than, you can say 0, we know that our result is too high. What we will do is our result is too high, we will take our right pointer and just subtract mate by 1. In the else case, if the result is greater than 0, you know that our number is very low, so we will just mate plus 1 in this case. And the else case, we know that we have found our number, we will just return m, and that's it.
Why, bro? I don't get it.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem.
Why is
value.
it?
In this case, a 5 is actually smaller than the real value.
Okay, this guy makes no sense sometimes.
S is greater than 1 based on the API function, so then we know, okay, 1 is not the solution, and now we're searching this.
Sometimes he says something to like sound smart, but just explain the question, bro. Nothing deep.
The number higher or lower. So in which they pick a number and we have to guess which number it is. And our upper bound is n and our lower bound is 1. So number will be between 1 to n, and they are giving us with n, and the number they pick. So our n is 10 and our picked number is 6. Also, they use an API called guess. So every time we have to check if our number is right or not, we're going to use this guess API to check. So first of all, what we're going to do, we create a variable low equal to 1. So our lower bound will be 1 and high equal to n. So high equal to n. After that, we check while our low is less than equal to high. If it is, what we're going to do, we create another variable mid equal to low plus high minus low divided by 2. So we find our mid variable and then we check result equal to guess mid.
Nigga, what? The more up you go, the more retards talking.
Hello and welcome. Today we're going to be playing the guess game from LeetCode, and the game is as follows. I pick a number from 1 to n, and you have to guess what number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. And we're going to be calling a predefined API called guess, which is going to return 3 possible results. It's going to be -1 if the guess is higher than the number I picked. It's going to be 1 if the guess is lower than the number I picked, or it's going to be 0 if you guess the number I picked exactly. Example 1, I have ending 10, which means our range is going to be from 1 to n inclusive. And I've picked number 6, but you don't know that. You need to figure out. You're guessing what number I picked, so you're finally going to figure it out in output 6. Here's going to be 1, 1. Of course, you're going to output what I picked. And same with example 3. This is a classic binary search problem. We don't need to scan through every single element from 1 to n to figure out what number I picked. We are just going to take our entire range, split it halfway, and see which half we want to search in. Now, I'm going to be giving you a cheat code for solving a binary search problem. Anytime you want to do binary search, you are always going to start with 2 variables on the ends of the ranges. Now, while these 2 variables don't meet in the middle, we are going to pick a midpoint between these 2 ranges, and we're going to see how that middle number compares to the number we're looking for. Based on that, we're going to adjust the 2 ranges and move that into
Latina.
So, say we have example 1 again, we have 1 to 10. So this is our input range over here, 1 to 10 inclusive. What we want to do is start off with our 2 variables on both ends of the ranges. So it's going to be low and high, which is going to be 1 and n respectively. So I have my low and high variables at 1 and 10. Now, while they don't meet in the middle, so while low is less than high, I want to find the midpoint of low and high. So mid is going to equal low plus high, integer divided by 2. Now this is 1 and 10 right now. 1 plus 10 is 11. Integer divided by 2 is going to give us 5. Regular division would give us 5. 0.5, but we don't really care about decimals. This is integer division. So our midpoint is 5 over here. Now we want to compare how our midpoint compares to the number we picked, which is 6. We don't really know what the number is, so we're going to be calling this API guess to see how it relates to it. So guessed is going to equal guess of that midpoint we have, and there are going to be three possibilities. Guessed is either going to be 1, 0, or -1. We want to move our variable in based on that. So if guessed equals 0, there's nothing for us to do. We pick the number exactly, so we're just going to return that midpoint we have. We integer dividing that by 2 is going to give us 5. Regular division would give us 5.5, but we don't really care about decimals. This is integer division. So our midpoint is 5 over here. Now we want to compare how our midpoint compares to the number we picked, which is 6. We don't really know what the number is, so we're going to be calling this API guess to see how it relates to it. So guessed is going to equal guess of that midpoint we have, and there are going to be three possibilities. Guessed is either going to be 1, 0, or -1. We want to move our variable in based on that. So if guessed equals 0, there's nothing for us to do. We pick the number exactly, so we're just going to return that midpoint we have. So we're going to return mid. Elif, if it's not 0, what if the number we picked is 1? So elif guessed equals 1. If that is true, the number we're passing in is lower than the picked number. So right now, 5 is lower than 6, so we're going to get 1 as our
just the API. Okay.
Hey everyone, welcome.
374. Binary search, yeah. Binary 1, 2, 3. That's 3. I think I can sort it by binary search too. I'll do 74 now. I need to do one more. Fucking hell. I've done already binary search. I'll do it one more time. So I need to target 4. I need to find the index of it. Okay. Oh, I like fat bitches with big asses, nigga. The middle value is gonna be, don't do that. 2, and I need to go if the target is bigger than the middle, I need to go. Okay, target is bigger. I need to move the left pointer by one. No, 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 no. If it is actually equal to m, I need to return m. Is bigger than m. If m is bigger than the target, I need to increment the left pointer. It's definitely not this deep. It's more like this. Fucking hell, bro. Why is -1 expected? Okay, that is some bullshit, but we ball. We ball. So, what question is it? It took me like 5 minutes.
Hey everyone, welcome.
7. Is it there? 7:04. Don't do that. I'm gonna do medium on the entire upper triangle before going on to the trees. I think that's a smart idea. And once I get to the trees, what's gonna happen is, where is the roadmap? Once I get into the trees, it's gonna be, it's everything is medium anyway, so I will like prioritize these two trees and these two and go into this dynamic. I will like max out. This will be my main tree next, main pyramid. And I would not go deep into the intervals, greedy, and none of that. I will go trees, backtracking, heaps, and priority queues and graphs. Those four will be the next area of focus, and I think DP. I don't really need DP, but I might like do a little DP. But for now, the main focus of area is the upper triangle and getting all the mediums in the upper triangle. Bro, look at me. Look at me now. So the blind 75 list is pretty interesting to look at. So let's look at the blind 70. Let's look at the blind 75. So he has one easy. It's all like medium questions. It's like the priority anyway. Yeah, it's difficult, but medium questions. A lot of them are medium. It's one hard question. Yeah, for me to understand the hard questions, I need to do medium questions anyway. So I don't really see the point of these questions. So these are the blind 75, which is hard to like get into, I think, for sure. Let's do all. Equal all. I've done 13. Oh my god. If I go 250, this is like the proper way to like learn too, I think. Before like jumping into the yeah, I think that's like a really good investment to make. Just doing the sums over and over again, getting in the concepts really like deeply understood. And yeah, the way he does it is okay. Let's see. Yeah, freeze isn't that important. Let's do a count, number count. I'm gonna, yeah, the hard questions, I'm gonna minus one in all of these. These are the main questions that I need, so it's 22. I'm done 13, okay. 22 plus 13, that is 35, 44, 58, 72, 76, 76 minus, okay, whatever. 76 minus, I wanna fuck you up. Okay, I'm cringe. Okay, I need to like solve another 63 questions on this particular quadrant, which is the important ones anyway. So, concatenation of arrays. Let's do this. I think I'm gonna go, since I've like did the basics in all of this, I'm gonna go like straight down. Complete this, all of this, complete all of this, complete all of this. Okay. There's a timer. Can I get a timer? Can a nigga get a timer, please? Oh yeah, I can do a timer on my phone. I should take, I don't know. How long should I take for an easy question in an interview? I'm gonna go 15 because I'm a amateur. 15 minutes for a solution, easy solution. Okay, 15 minutes. Let's go. Let's look into the problem. You're given an integer nums of length n. Create an array ans, length of 2n, where ans this is equal to this, and for okay, let's look at the, let's actually look at this thing. So I need to concatenate like both of them. Yeah. So before jumping into the code, I'm gonna return the ands. I'm just gonna. Is there a time complexity to it? A 2n. Cool. Okay. So I think it's pretty relatively easy. I don't think I need to use a for loop for it. I could just concat is equal to I'm sorry, conc. Ah, yeah, that's an easy one. Okay, let's do another one. Okay, let's go. You're given an array of string str, return the longest common prefix of all strings. Okay, I need to return the common prefix in all these strings. Okay. Oh shit. Okay, give me a second. I need to record everything that I do. And this is such an easy question. Should I even?
Hey everyone, welcome back.
Bro, you kidding me? Are you? You gotta be kidding me. This is like trolling.
Pretty much have the result and we can return the answer. What I like about this solution is it's generic. Like what if the interviewer asks you, now write code that will do this 3 times or 4 times or concatenate 5 times, or maybe there's a second variable basically ask you this to make sure that it works. What we want to do is take every number in.
This is like so retarded. The way it does it. 1929. I think I've done it. That's so true. That's so true. Okay. Let's redo this again. Okay. You're given in a string array, return the longest common prefix of all strings. So I should go over. Does it have a time specificity? Okay. What we're gonna do is we're gonna take the string index of 1. We're gonna get the output is equal to nothing, right? And for I in length of num, we're gonna iterate over that many times. Okay. For j in I, we can do that. This will be the brute force solution. For j in I, we're gonna get we're gonna check if the first how do I do this? Okay, I've never done this. There's no way I can get this. So this is the answer. Let's understand this before the time ends at least. If length of string is equal to 1, return, okay, that makes sense. This is sorting, vertical scanning.
Hey everyone, welcome back, and let's be shorter this string and this string, right? We're gonna have to strings, then you could say this is the time complexity, right? That said, we're string, right? I'm used slightly differently than using a conditional is the first string in the input, which means it's.
So you're not even using anything from here. So what the fuck, bro? So you're taking an empty string for I in range, for S in string. If I is equal to R, return results. Oh my god, bro. Oh my god. Yeah, this is. Let's redo that. Remove element. Let's look into this. Okay, you're given an integer array nums and integer val. Your task is to remove all occurrence of val from nums in place. After removing all occurrence of val, return the number of elements, say k, such that the first element of k do not contain val. Okay, I just have to remove every instance of this value without changing and returning the exact same way. The order of element, okay, does not matter. It is necessary to consider the beyond the first element, position k. So removing an element, okay, for return k as well as final result. So I need to return the number of, okay, what? So I need to return the indices. So for I, can I? Don't do that. What? Length of nums, okay, and I need to go over every. This will be the length. This will be the iteration, so I need to go if I find. How do I like delete it? I can use 2 pointers, what the fuck? That's what I was thinking, 2 pointers, okay. I'm gonna use the left pointer, it's gonna be 0. So if I find so if value is equal to nums of L, shit. I need to go. Ah, oh fuck. So if nums of I, the first element is not equal to value, okay, then ah. Okay, let's go nums of. Apparently this works. I don't even know how. How? Okay, L.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem remove array to look like in the array that are not 2. And like I said, the 2's, right, replacing this A, or let's call it shift A. Let's say the A really makes sense. Okay, K gets incremented by 1 to over here. swap it with itself, swaps with itself, swap this with itself, and then we're done. And then by the end of it, our k pointer would be over here. It would be at position 5. And we would want to return 5 because that's the number of non-2 values in the array. And then this is what our array would look like. We didn't actually modify the array at all if this was the input array itself. We arrive at this 2. Would we want to put the 2 over here? No, because we only want to put non-2 characters at the beginning of the array, right? We don't care about the actual 2 character. And I've been using I for this, but it's probably better to use K. This K value will actually be the output value that we end up returning in this problem, because this K is going to be incremented every time we see a non-2 value. So it'll tell us by the time we've reached the end of the array, it'll tell us how many values are in the array that are not 2. So that definitely makes sense for us. Now, one thing you might be wondering is, we initialized our k pointer over here, but isn't the k pointer initially going to be at the beginning of the array? And suppose we didn't even have any 2s at all. What are we going to do in this case, right? We're going to say, okay, we have a 0. This is not a 2, so does that mean 0 is going to be swapped with itself? That doesn't really make sense. And then would we want to still shift our k by 1 because we didn't see a 2 in this position? And you're right, it doesn't really make a lot of sense to do it, but it elegantly does work out with the code, right? For example, if we did not have any 2 characters, right? Suppose these didn't exist and this didn't exist. How would the algorithm that I'm explaining, how would it actually run? Well, we'd see a k. We'd start with a k here. We'd say, okay, this is not a 2, swap it with itself. Okay, then k gets incremented by 1. This is not a 2, swap it with itself. Okay, k gets incremented by 1 to over here. Swap it with itself, swaps with itself, swap this with itself, and then we're done. And then by the end of 5, because that's the number of non-2 values in the array. And then this is what our array would look like. We didn't actually modify the array at all if this was the input array itself. So you can see that this algorithm, it's simple, but it does work in all the edge cases that we need it. So now finishing through every a 2 value that the equal, and I'm writing all of them. So that's what we're like. Increment by 1, and then if it is that special value, then we won't do anything, we'll just skip it. And then once we're done with this, remember what we actually want to return is k itself. We don't want to return nums, we want to return
Hey guys, Greg here. Let's solve remove element, leak code number 27. So we're given an integer array called nums and another integer called val, and we need to remove all the occurrences. These don't matter at all. They don't have to match the same order as the original array. If it did, it would be 0, 1, 3, 0, 4, but they actually have 0, 1, 4, 0, 3. And so any permutation or rearrangement of these numbers here is totally okay. As long as you keep the numbers you want to keep and you return how many you kept, that is totally fine. We need to do it in the space of the original array, and at the end, it doesn't matter. Okay, so say we're given this array and we're trying to remove all of the 2s. Okay, so we're trying to remove all of the 2s. Okay, so what we're going to do is place an index I at the 0 index, and we're actually going to think about this index as n minus 1. So if n is equal to 7, there's 7 elements in the array. Now we're starting at the front here. Do we want to keep this number? No, we want to remove this number because it's a 2. But what we do is not just remove it because we want something else to be here. What we set it to be is what's at n minus 1. So we would set this to be a 4. And when we get rid of a 2, what we're going to do is move over our index n minus 1. And really all that means here is just decrementing n. And we are definitely not going to move over I in this scenario, but we need to watch out for that. Okay, now on this iteration, we're going to remove it, and we're going to place keep this number, so we're going to move past it. We can move past that and move past this, and we're onto a 2 over here. We are going to remove it, and we're going to place with it what's over here. But it is a 2, and we're still going to move over n minus 1 here, so that just means we're going to decrement n. But then on this iteration, we're going to see again, hey, this is still a problem. We have a 2 here, and so we're going to place with it what's at n minus 1. Well, it is now a 3, because that one shifted over, and we're going to shift over n minus 1. And so that moved n down to 4, and notice here, we are completely done, and we even know the value of k. K is equal to 4 here, and so even though there's a 3 and a 2 and a 4 over here, this is just garbage to us. We don't care about this stuff here. What happened is when I and n minus 1 hit the same element here, that means that we've removed all of the garbage, and it even tells us how much stuff we have left. We have 4 things left to keep, so we would just return whatever n is at the end here. So this is going to have a time complexity of big O is completely get n, I is less than n, if nums at I is equal to val. So if we're on something we want to, at the end of this, almost miraculously, you can return n, and that's going to be the amount of stuff that we kept. Because think about it, we start with n things, and then basically whenever nums at I is equal to the val, you're going to decrement n, and that both shifts it over and actually decreases the number of things that you had. And so at the end,
You can use it with a 2 pointer. Okay. Is the time gone? I got 2 minutes left, bro. I can do this. Easy work. So instead of doing it this way, 2 pointer, we're doing the 2 pointer way. So we're taking the left and the right is equal to 0, comma, length of nums minus 1, while L is actually bigger than R. We're gonna, if nums of L is equal to nums of R, if both of them are equal, no, it's uh, I'm just gonna decrement R minus R is equal to 1, and else I'm gonna increment L plus and return L. Shit. Yeah. Okay, got it. Let's do it one more time. So we have this and this. And why is this thing equal to length? It's because the end of the... Why? That doesn't make any sense. Fuck. So it's num for some reason. It's just pointing to the last element. I think that's the reason why. So if you go this way and go using the left pointer as like a pointer to like change it. So if this is equal to the val, And if this is equal to valve, what we do is we just like decrement the last element. Decrement the right pointer, and we're gonna actually swap this one with this one because we don't actually need the. We want a garbage. We're gonna like chuck out all the useless elements that we don't need into the last array, and yeah, we're gonna do this. We're gonna yeah, I'm gonna do this one. Cool.
Stuff we don't want to remove.
27. Okay. Ta 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 ta. It's sunshine and rainbows out here, man. Major element. Let's go. Given an array nums of size n, return the majority of element. The majority of element is the element that appears more than n comma 2 times in an array. Okay, you're assuming. Okay, let's. Okay, Medj is gonna be length of nums divided by 2. So for I in nums, range of length of nums, it's gonna be is iterating over the loop, and we're gonna find. We have to count. We gotta count the majority of elements. So when something is a majority, like this one right here, 5 is a majority. We're gonna add that to a. How does he do it?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem majority element. I probably should have solved this problem earlier, but don't let you. We can use any
You're using hash map. Okay, count. Max count is. Oh, fuck off. What the fuck is this? Count is equal to default ticked. I wanna like kill nigga. What the fuck is this, bro? The fuck is this problem? I don't know how to use hash map and sets.
Hey guys, Greg here. Let's solve majority element, leak code number 169. So we're given an array of nums of size n, and we need to return the majority element. So the majority element is the element that appears more than n over 2 times. And this little symbol here is the floor, so rounded down. So you may assume that the majority element always exists in the array. So the examples are pretty clear. If you have 3, 2, 3, then the majority element is 3. And if you have 2, 2, 1, 1, 1, 2, 2, well, there's 4 2s and there's 3 1s. The majority element would be 2. Okay, let's use this example here. So we can see we have 5 2s here, and there's 9. Many elements. So we have 2 appearing in over half of the array. positions, therefore it is the majority element and what we'd return. Now the first solution that comes to mind is building up a hash map, where basically you would have the key as the number, so we'd have 3, and then the value is the number of those occurrences. So there's 2 3s, so of the 3s, we have 2 of those. You could go through the entire array and accumulate that you have for to be the one you could get to take a time. Because we store that, we'll use the array. If that num is already in the counter, so if it's a key in that hash map, then we'd set counter at the num to go up by 1. And if the number is not in the counter, aka the else, then we'd set it. So counter at num is equal to 1, meaning that we have not seen this before, so we'll say that we have one of these. Okay, after this, our counter would be completed, and we'll initialize 2 variables, basically to dummy values. We'll set max count equal to -1 so far, and same thing with the answer. So max count is going to go and find the highest frequency, and answer will be the number that's going to be associated with the max count. Okay, then we can loop through the dictionary. So for each key and value in the counter.items, that loops through the key value pairs. If the value is greater than the max count that we've seen so far, then you'd want max count to be that value, and you have an updated answer so far. So we'll set answer equal to the key. So after this thing runs, we're going to have max count as the highest value, and we'll have answer as that key that's associated with the max count. So that after this runs here, you can simply just return your answer. So this is going to work, and the time complexity of this would be big O of n. The space complexity is also going to be big O of n. So if we were to submit that, that is going to work, but we can get a better solution than this. Okay, so the idea is to so far have a candidate, which I'll just call answer like we did before, and that's going to be initialized to whatever, we'll say -1. And we're also going to have a variable called count, which is going to be initialized to 0. Now we'll loop through the array from the beginning, so we'll start at the 3 first, and we basically ask these 2 questions in order. Firstly, is our count equal to 0? Yes, it is, and because the count is 0, that means we're going to update our answer to the number we're currently looking at, so answer is going to be set to 3. The second question is our current number matching what our answer is? Yes, actually it is, and therefore we're going to increase the count. So we basically say we have 1 count, it's kind of like a tally for this potential answer that we have. Okay, and we keep following that rule here, so we go through and we see a 2. Okay, well our count is not 0, so we're not going to update our answer. However, this current number of 2 does not match our answer, and so when that happens, we actually decrement the count. So this count is going to go down to 0. That's going to cause this to happen. When we look at the next number, we ask the question, is our count equal to 0? Yes, it is. And so when that happens, you update your answer to be your current number, which is going to be 1. Now, whenever we update our answer, these 2 things are always going to match, and so our count is going to be equal to 1. Okay, we move this over here. The count is not 0, so we don't update the answer, and this actually matches our current answer. So the count is actually going to go up to 2. You can see our algorithm is kind of trying to suggest that 1 is looking like a good candidate so far. Okay, then we'll look at the next number here, and we see 2. Okay, well the count... And so
That is
the count
actually
is
so
going to go
fucking stupid. That's actually so fucking
back down
stupid.
to 0. This means that next time when we go over here, our answer is actually going to be set to our current number, and so it's going to be set to 2. You can see we basically just lost our ability to think it was 1 because we saw 3 2s in a row here. And so we will get a count is equal to 1. When we move over here, our count is equal to 1, and so our answer does not match. We are going to set our count equal to 0, which actually makes it over here. That will actually cause our answer to basically be reset to this last number, which happens to be 2, and that's going to end with a count of 1. And ultimately, you would return our answer. So why the heck does this algorithm work? It's really weird, isn't it? I handpicked this example because I think it's very interesting to see that basically all the stuff that we did up to this point, it really didn't matter. It ended up just getting set to this last number here. Now, while that's not always the case, it shows the intuition. If you have 1, 2, 3, 4, 5, 6, 7, 8 elements here, well, if you didn't find the majority element here, then that means that it must be over here. And since there's only 1 element here, it's actually going to be set to that number. So if there was actually a 3 here, well, then it would have to be 3. But that doesn't work because that's an invalid example. Because you know that the majority element exists here, there is a number in the array that occurs in over half of the array's positions. If you've looked at all of this stuff here and you didn't find it, then it's got to be over here. Same thing if it was a different example, like it was a bunch of 2s over here, so we'll say 2s over here. Well, if you did find it over here, which you would, if you look in over half the array's positions here, well, then the count's actually going to be so high here that you actually can't get it away from being 2. Even if all of these were 1s, for example, it's already been found at this point, and so your answer would still be 2. Okay, so the idea is to set our answer equal to any initialization. We'll just say -1, and the count is currently equal to 0. Then we're going to do exactly what we said. For each number in the numbers array, first thing you do is if the count is ever equal to 0, we're going to update our answer to be the current number. Now, regardless of whether that happened or not, if the answer is equal to our number, then the count is going to go up by 1. So if they are matching, then we have basically more proof that that is our actual answer. And otherwise, if that's not true, then count is actually going to be decremented. So it will go down by 1. If we didn't match, we basically lost proof that that was the majority element. Okay, and after this is true here, you will actually have set answer to be the correct element.
Hello guys, welcome back to TechDoors, and in this video we will see the majority element problem, which is from Lead Code Day 6 of the May challenge. So let us look at the problem statement. The problem is very simple and it says that given an array of size n, find the majority element. And the majority element should occur more than n by 2 number of times. So this is n by 2 floor. So it should occur more than n by 2 number of times. So if your n value is, let's say, 5, then your n by 2 floor value will be equals to 2. So if there is a majority element in your array of size 5, then it should occur more of elements. Say that array will be happy. Now we will iterate for the rest of the element and reassign the majority element. So we will assume that this 2 is now the majority element, and we
Hello and welcome back to the Cracking Fan YouTube channel. Today we are solving another easy problem for some of those people that are just joining the LeetCode grind. It is a 169 majority element. Given an array of nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. So let's look at some basic examples. We have an array of size.
Okay, I need to mark down. This will be a task for me. I need to mark down the subtrees of all the ways a problem could be done for the upper triangle and do the easy questions. Okay, let's look at
There's
this.
3 here, there's 3 with 3 times.
Should I